So yesterday on 4.1, I think I made that harder than it really was. I think I should have just told you, here's how easy it is, let's do it. So I just want to do a simple one where it's a composition. So you remember what the compositions were on the assignment?
Say like translate it here and then translate that.
Exactly, where you're doing more than one translation. We're moving it and then we're moving it again. So there'll be two rules, something like XY is mapped onto X plus 4, comma, darn it, and then Y subtract 3, and then XY is mapped onto X plus 2, comma, Y subtract 5. So let's say we have a figure, and I'll just draw the figure here, make a nice simple little one. And I'm going to call this figure PQ, triangle PQR. And we're going to map it. So usually in this book it always starts with the pre-image being blue, right? And then the image is red. And so we're just going to do that. And we're just going to take every single point. We're going to use this first mapping function that is in coordinate notation, right? Coordinate notation. And we're just going to go to the right 4, 1, 2, 3, 4, and down 3. And what are we going to call that point? P prime. So that we know where it came from and that they're related, but we don't want to name it the same thing. And then we're going to do the same thing with all of them. So Q, 1, 2, 3, 4, 1, 2, 3. So here's Q prime. And then R, 1, 2, 3, 4, 1, 2, 3. And there's R prime. Now, when they did a composition, did you notice that the third figure they did in green? Okay, and again, that's just in this book. There's no rule about that or anything. Okay, so we're gonna do this again. So we're gonna take this one now. We're gonna go to the right 2 and down 5. So to the right 2, 1, 2, 3, 4, 5. And what are we gonna call that point? Okay, so we're going to call it P double prime. Boy, someone was a genius that thought that one up, right? Okay, it's actually pretty simple, isn't it? So then here we're going to go over 2 and down 1, 2, 3, 4, 5. And that's going to be Q double prime. And then R is over 2 down 5. And there's R double prime. And you notice that hopefully each of your figures should be congruent to the pre-image, right? If your figure changes shape or rotates or flips or something, you did not do the translation correctly, did you? Okay? So that's all there is to it. And I did want to point out that if we add these together, XY is mapped onto, and by the way, we call these a mapping function. Does that make sense? Mapping function too. If we add the x things, we'd get x plus 6, which is kind of an odd way of adding. Like if we added these together, you'd almost think it would be 2x plus 6, wouldn't you? Right? But we're just adding what's going on with the x coordinates and what's going on with the y coordinate. So that would just be y subtract 8. And you'll notice, can we go from P to P double prime by going to the right 6 and down 8? Yeah. Right? Okay. So that's all there is to it. That's a translation. I didn't seem like you had any problem with it or questions at the end of class yesterday. Is there something I can help you with? 38. 38. I might be able to do it if I can find my glasses. Mathematical connections. The vector PQ describes the translation of this is cool. Okay, so we're having to think a little bit. describes the translation of point A, here's point A, -1 something. It doesn't tell us the y coordinate of point A, does it? It just gives us the x coordinate. Onto A prime, which is 2x plus 1, comma 4. And point B, which is 8y subtract 1, comma, what in the world happened there? We got to ignore that, comma 1. And then to B prime. So the same thing's happening. From A to A prime and from B to B prime, this mapping function is happening on both of them. And B prime goes to 3 and then 3z, which we're not really sure about. Okay, thank goodness there's no point C. So, think about what's happening. We're starting with an x coordinate of -1, right? And we're doing this mapping function right here. And what are we going to do to every x coordinate? I'm pointing at it, guys. What are we going to do to every x coordinate? Add 4. And then where do we end up? Where do we end up? I'm pointing at it. Good job. Okay. So we're starting at -1 in this x coordinate of -1, right? And then we're doing this mapping function. We're adding 4. We're going to the right 4, so I'm just going to add 4. And we know where we end up. We end up at 2x plus 1. So I propose that 3 is equal to 2x plus 1. Or that 2 is equal to 2x, or that x equals 1. What do you think? That seem logical? Okay, let's do the y part. See, we know we're starting at w, and then what are we going to do to this y coordinate? We're going to add 1, and where are we going to end up? At 4. So w must be a 3. Let's go over to point B here, so to find our y. So we know we're starting at 8y subtract 1. And again, we're going to use the same mapping function, aren't we? So we're going to add 4, right? We're going to do that to every x coordinate. We're going to add 4. And we know where we end up. We end up at 3. Everybody following me? Raise your hand if you're following along with this. Raise your hand if you're not following along with this. All right, I'm going to trust you. All right, so 8y plus 3 equals 3. 8y equals 0. So y equals 0. And then, finally, the y coordinate here is a 1. And we're going to add 1. That's our mapping function for the y's. And we're going to end up at 3z. And so 2 equals 3 times z. And I think we can just divide both sides by 3. And z equals 2/3. So we're just making equations based on where we're starting and then what we're doing to the x coordinate and where we're ending up. And the same thing with the y coordinate. That's a good question. Let's go down. Didn't we do 44 and 46? Okay. You probably don't have a question about that, but that's leading us into our next part here. So, tell whether the figure can be folded in half so that one side matches the other. And it appears to me that 44, that this leg is a little longer than this leg of the right triangle. And I don't even know if it's a right triangle. It doesn't have a right angle marker there. But can we fold it some way? Thanks. Could we draw a line through here and then fold this across the line, and so that half of the figure folded over exactly on top of the other one? It maps onto it. What do you think about that? Who says no? I see a lot of head shaking. Okay, that's right. There's nowhere that I can draw a line through here and then fold my paper on that line and make that figure map onto itself. Now, 46, on the other hand, is there a line on this one that we can fold it? Yeah, this we call the line of symmetry. So right there along that line, if we were to fold the paper, we could map the figure right onto itself, couldn't we? Okay, so we could call this a line of reflection. We can call it a line of symmetry. But that's leading into what we're going to talk about today. Okay, there's 25 possible. Give me a score. Hand it in.